Today we're going to look at linked lists. So before we get into lists, let's talk about the difference between linked lists and arrays. So we can make a list out of an array or a linked list. What's the difference? So for an array, it's statically allocated, and the size cannot vary at runtime. Cannot vary at runtime. Contrary to this, a linked list is dynamically allocated list. So we don't have a contiguous block of memory. And the size can vary at runtime. All right, so how do these two attributes for each of these play into their implementation as a data structure? So for a linked list, I'll say there's no memory wastage. There's very little memory wastage. And we can insert elements as long as there's memory available. So as long as there's memory available, we can insert elements. Insert elements as long as memory is available. If you're watching this, I'd recommend grabbing a piece of paper and jotting these things down as we move through the video, because I'm covering the theory and then we'll cover the implementation after this. Now, for an array, if the data is less than the size of an array, so let's say you allocate a bunch of memory for an array. You allocate a size of like 100 and you only use one block of that memory. Then you waste memory. Let's say that you allocate some memory and the data is greater than the size of memory that you allocate. Then you're going to have what's called an overflow, data memory overflow. Okay? So this is a pretty good contrast, at least in my opinion, of arrays and linked lists and how from a memory standpoint, how they're different data structures. From an implementation standpoint, of course, if you've ever used an array, I would argue that arrays are simpler data structures to use and linked lists can be a little bit more complicated. So let's cover the pieces of a linked list. Okay, so this is probably going to be one of the first times that we're going to see a struct type in C. So for a linked list, we will use nodes. Visually, what does a node look like? Well, we're going to have the head of our list, which we'll call start. And then we want to have these things connected by links, pointers. If you don't know what pointers are, please go back and look at the video that I made on pointers. Spend a fair chunk amount of time on that so that no one would have an issue with this video. So we're going to have pointers linking all of our data together. So we're going to have our link and our info part. And this is all going to be linked together in a chain, and then finally it's going to terminate when we have a null piece of data at the end. Oops. Put this in the wrong spot. So here's our link, and it's null. That's the data that's stored in there. There's nothing stored in the last one. So this is kind of like a linked list that has just two pieces of data stored in it. Info 1, info 2, link 1, link 2, link 3, Link 3 is the end of it. So what does this abstract thing look like in C? Okay, so we're going to use what's referred to as a struct type. If you're coming from any other programming background, a struct is pretty similar to a class in a sense that it can contain members and it's public, everything is publicly accessible. So this is kind of the primitive version of a class. You can think of it like that. So in a struct node, we're going to have our types, and we'll have member 1. Oops, not types. Type member 1, and then type member 2, da 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 da. And then finally we want to, this is all the stuff that we're going to store in info. And then we're finally going to have our struct node link. So we're using the type that we just made. We're going to use a pointer, struct node pointer link. That's the thing that we're going to link to. Right? We want to be able to take this and point it to another struct node. Okay? So for our example, we're going to use a struct node. And in it, we're going to store some info and struct node pointer to our next node. This is our link. This is like the arrow in the diagram that I drew before. This is very similar to the arrow. So this is going to give us something that looks like this. Info. This is what this represents abstractly. Okay. Let's see how we can create a list and then how to traverse that list. So we're going to cover inserting elements into a linked list. Basically, we want to be able to generate a linked list such that, oops, I have the eraser selected, such that we have our start head, and then we want to be able to connect from our start head to our first node, then our second node, to our final node, and for example, in this type of list, we could have, I don't know, let's say that we have like the memory address, this could be like 450 and 720 and 300. I'm not sure if this is 30. How about that, 30? And I'm not sure if this is exactly how it would look. So you see how this is not a contiguous block of memory? If we have an array, let's say we stored like 10, 3, and then there's nothing there. If we had an array, our array would have to go in a block of memory. 450, we'd store the value 1, and then 451, we would store the value 3. And this is the difference between an array and a linked list. This is an array, and this is a linked list. You see how the data is stored differently? Or you see how the memory is different? We're using memory differently in a linked list. I really want to stress that concept that we're using memory differently in a linked list. It's not just a block of memory. It can be created dynamically. Okay, so we need to look at a couple cases for insertion. So we need to look at insertion in the beginning of the list, insertion in an empty list, insertion at the end of a list, and insertion in between two nodes. So before we cover any of those things, how do we do this stuff? How do we insert stuff into a linked list? Let's say we have start. I just erased this, but let's say we have start, and we have a node, and this is connected, this is connected to the last node, which is null. So we want to put something at the beginning of the list. So what we do is we make a temporary node. We'll call this struct node star temp. We'll declare this temporary node. Now the thing about C is you have to allocate memory. So when we allocate memory in C, we got to first use the malloc method for allocating memory, and then we have to pass in the size of memory that we're allocating, and we need to also cast it to the type that we're using. So this is kind of a big line. Struct node, we're going to do casting, so you can cast it to a struct node pointer, and then we have to use the malloc. Yeah, this is kind of a mess. Malloc. We'll just say this. We allocate memory for temp. Okay, we'll look at that in code. So first we declare temp, and then we allocate memory for temp, and then we have to store some data in temp. So temp, this is how we can access a member off the struct. We can do temp arrow info, and we'll set this equal to some data. You know, something that you would declare at the beginning, whatever. Now, how do we insert this in the beginning of the list? Well, we want to be able to connect an arrow from here to here. So to do this, that would be temp link. We're going to access the link member. Remember, that's a struct node pointer. And we're going to set that equal to the start pointer. So what that's going to do is it's going to match the arrow from temp to the arrow from start. And then we want to be able to break this arrow from here and point it to temp. So that's going to be start pointer equal to temp. Do you see how this works? We're basically moving arrows using link. So that's insertion in the beginning of the list. Now I want to cover insertion in an empty list. Let's say that we just have a lonely little start head over here, and it's null. How do we insert a new node into this list? Well, we go through the same procedure. We make a node called temp. We allocate memory for temp. Then we point temp link to null. So this guy's going to be null. And this has got, even though it's null, it still has, it's a pointer. So it still has an arrow coming off of it. So we're going to match the temp link to start link. See how they're both null? So we could say temp link equals null. This is going to make our pointer null. And then all we have to do is point start to temp. It's going to move our arrow right down here. So this is how we do insertion in an empty list. Now what if we have a list that has a bunch of elements stored in it and we want to place something at the end? So we have start. Start's pointing to a node. We have another node. We have another node. And then finally, the end of this is null. How do we insert something all the way down here at the end where everything is null? So the first thing we want to use is a pointer p. So we'll say p and we'll start here. So we'll say p equals start. And we want to constantly move P from place to place. So P goes there, then P goes here, then P goes to the next one, then finally P goes to the last one. But at this point, P should be null, right? Because we're at the end of the list. So we're going to start P at start, and then while P is not equal to null, we're just going to keep on saying P equal to P link. We're going to keep on moving it down the chain. So we're going to go P equal to P link, and that's going to move us all the way down to the end of the list. I'm going to move this brace up here. Okay, so now we're finally at the end of the list, right? If we go through this while loop, we're at the end of the list. Should be semicolons at the end of each of these. And then we finally do the same old temp insertion. We just make our temp node. And then we can set temp, we can set P link equal to temp, and then temp link equal to null. So we'll take the link from here. Not from there. No, this guy. So P link goes to temp, and then temp link equal to null. So P link equals temp, and then temp link equal to null. There we go. Okay, so the last case we're going to look at is inserting a node in between nodes. So we can use the same picture that we had last time. All we're trying to do is place a node, say maybe like right here in between these two nodes. So we're still going to use that same P link. So we're going to start P here, and then we want to move P continuously down, 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 until finally we get to here. So at this point, P is going to be at this position. And we're going to say temp link, our arrow from temp. First we got to declare temp, and then a temp link equal to P link. Puts an arrow right here, and then P link equal to temp. We'll take this arrow here and move it to temp, and we've just inserted a new node in there. So let's go over the implementation of how to create a list in the next video.